Well, we should be live. And thanks everybody for tuning in. We've got major space weather on the way. So NOAA is already forecasting, or at least their initial reports were for a KP6 to KP5 to KP8. So that's a significant solar storm. There was an X-class solar flare and a pretty much dead-on Earth shot. So there's some solar plasma on the way to your back door. And yeah, it's the likelihood of mid-latitude aurora is actually very high. So that's what we want to see on the channel. And since my voice is still shattered here, we'll still recovering from secondary infection following the flu. We'll talk about space weather stats. So yeah, delighted to have you. Although I see nobody in the live. So make sure you leave a comment. Let us know you saw the video. Let us know if the algorithm shows you the content, if you've pressed the subscribe button. And if not, I guess you just want to miss content. So whatever. So yeah, exciting stuff for space weather types. And our regular viewers are certainly space weather types. So let's talk about things like sunspot number, which is up around 150, I think. And not really too big of a surprise there since we are in proximity to solar maximum. We're only about a year beyond solar maximum here. So, you know, the ramp up and the ramp down after that, that's like 3 years of solar maximum-ish conditions. Speaking of which, here's a nice view from the GOES 19 SUVI of the closest star. My favorite one to gaze at. And if you're into astronomy and you're not looking at the closest star, what the heck are you doing? I mean, the closest star is the most interesting one. It affects you directly in all sorts of ways, obviously. All right, so there you go. There are the past couple of hours. Let me shrink it down one more size. There we are. There's the full image. And thanks for leaving a comment. Thanks for saying hi. Hi, Jesus is Lord and Savior. That's a long name. Have a blessed day as well. All right, so here we go with some stats. Cosmic ray flux remains at a 20-year low. So if you look at the Oulu cosmic ray station right here under my pointer, you can see we have not had this low of cosmic ray levels since 2004. This is not surprising because this solar cycle has been much stronger than solar cycle 24. It's not even close. And hey, thanks for the comment, Stratotanker 837. Yeah, we've our band, interestingly enough, we've formed a band. We're a three-piece right now, and we haven't ever played together. So we're gonna record a bunch of songs remotely, and then when we have enough songs to play a show, I think we're gonna stay a three-piece. I don't know, because I see some amazing three-pieces out there, like Rush and Karangbin and Primus. So I'm pretty sure we can do it. Anyway, back to cosmic ray flux. We're at the lowest levels. And by the way, the other monitors will agree as well. If you go to Mexico or Athens, Greece, or Barentsburg, Apatit, DOMC Antarctica, DOMB Antarctica, cosmic ray flux lowest levels since 2004. So if anybody who does space weather claims that spooky energy from space is increasing and it's very dangerous, what energy? What energy? You mean UV light from the sun? That happens during a solar cycle. You mean X-rays from the sun? Well, they're not detectable at the ground level, but okay. But energy from space is definitely not decreasing because the solar plasma acts like a shield around the solar system and prevents cosmic ray flux from making it to our ground-based neutron monitors. So anyway, moving right along to the Huxt forecast, and you'll see a CME headed right toward Earth, I suspect. Let me just press refresh to make sure that we've got the latest Huxt animation there from University Reading. Wait for it. Here it comes. It happened. Oh, what the heck? Look at how old that is. All right, that's nothing. Anyway, moving right along, sunspot number is currently at 161. 161 sunspots. That's impressive. Coming all the way up from, I don't know, 15 sunspots. So this is normal. These wild gyrations are what you see at solar maximum. That is nothing special. 10.7 centimeter radial flux here, higher than it was. No surprise there, pushing 180 solar flux units. 180 solar flux units. If you're wondering what that is 10,000. A solar flux unit is 10,000 Jansky. That's just a measure of radial flux density traveling through a vacuum. Next is our space weather enthusiast dashboard. And as you can see here, now wait, let me refresh. It's refreshing to refresh. Tomorrow night into Wednesday morning, expecting a major geomagnetic storm. Now, NOAA has downgraded their forecast here because I saw KP 5 to 8. Now they're only forecasting KP 6, but we could certainly see a KP 8 from the nearly perfectly directed Earth-facing CME. So here's the current solar wind conditions. It looks like we actually just had a little minor impact. There's been a lot of solar plasma headed our way. So right now the BTBZ is total field is only 5 nanotesla, so the field is kind of weak, but there is a negative BZ that does help to facilitate geomagnetic storm conditions, but we're not going to get there at the moment because this is a weak magnetic field, and it's yeah. So anyway, current conditions are about 7 protons per cubic centimeter, traveling at about 570 kilometers per second. That's over 1,000,000 miles an hour if you're keeping track. And check it out, we got a proton event. So we did have the greater than or equal to 50 mega electron volt come up a little bit off the baseline. So this is a significant proton event. If you're doing a polar flight or if you're an astronaut, you will be exposed to a little bit more radiation than normal when this is baseline lower. Those protons, they're orbiting Earth's magnetic field lines in a very fast fashion because we're talking about 10 million volts and 50 million volts for those SEP, solar energetic particles. So obviously it was associated with this, and we had another X-class flare today. How cool is that? Stoked about it. Stoked. All right, so let's see what we got on the LASCO, as we may have another major CME headed toward Earth. Let's, fingers crossed. Everybody, please simultaneously cross your fingers. All right, so check it out. This CME happened at about 9 o'clock Universal Time, as you can see here, just after 9:10 on November 10th. Oh, yeah. Look at that. That's a high-speed one. Guys, we got major space weather on the way. This is legit. So that's another Halo CME. Exciting stuff. Let's check stereo A. We're going to bring up some fresh data for you here. You'll learn about it at the same time I do if you're viewing live. And if you're not viewing live, why don't you press subscribe so you see the videos when they are new? We regularly cover these things long before anybody else hopes to. So here's stereo A. And by the way, we don't sprinkle any nonsense in our space weather coverage. So let's see. Here is today's data, we hope. Do you got it? They got it. It's going to be there. Look. Yes. Oh, yeah. So look, the Earth is off in this direction from stereo A. Earth would be out here somewhere. And look, there is an Earth side CME. So there's actually one on the far side as well. Let's just see if that's high speed or not. Oh, yeah. Oh, yeah, that's high speed. That's another geomagnetic storm. So late in the day on the 12th. Late in the day on the 12th. So another CME headed toward Earth. How you like them apples? We like it. Continuing right along to look at the heliosphere's magnetism. First, we'll look at the line of sight coronal hole plot. You can see the way the solar B field shown here in blue is all fanned out. That's because Earth has a bunch of Earth-facing coronal holes right now of South Pole orientation. You can see them up here in the north major coronal holes pointed right at us. Here are the sector boundary crossings. Earth remains in a South Pole magnetic sector. Looks like no changes recently for that. South Pole sector shown here in red, North Pole magnetic sector shown in green. Here's a recent impact at the Boulder magnetometer. You can see there are some variations. And this could kick us into geomagnetic storm conditions because that magnetic field can suddenly vary a lot. Next, we'll look at El Teide, Spain. I want to see what these... Oh, look at the magnetic shear. Look at these sunspots, folks. That is what you want. Yowzers. Yo, look at the magnetic shear. You see there's white and black starkly right next to each other? This is still an X-flare producing sunspot. So this is not done flaring in all likelihood. This one down here looks promising as well. This one's got flare potential. There's even flare potential out here. So a lot going on. And it's an exciting day for space weather, to say the least. You're going to hear all about it on the internet. People are going to tell you to get into your bunker. We're all going to die. And if you think the sun's going to kill you, the sun is your friend. It's the source of all life and light and heat on the planet, for the most part. Besides, I mean, you can make the argument that geothermal heat is not solar induced, but depending on how you think the solar system formed, that's still from a star. So anyway, if you think the sun's going to kill you, press unsubscribe if you're subscribed to the channel, because we read all comments and we don't need more dumb ones. All right, so let's look at these sunspots. El Teide is not looking so clear. Cerro Tololo is probably a little bit better because it's located in the Atacama Desert. Oh, yes. Look at them sunspots. They're looking stable and volatile. Those are volatile sunspots, folks. Nice. That's what you want to see. You're welcome. Continuing right along to look at filaments. And I suspect we're going to see one blasting off once again. Oh. Hey, and by the way, it looks like the filament that's on the way to Earth, the one I named the Bob Lehman filament, it was down here. I think that's the one that's going to strike in a day and a half. So yeah, the Bob Lehman filament, at least part of it, is on the way, folks. You can see this flare happening right in here. And part of this filament looks like it blasts off. We're going back. Now let's go forward again. So let's see. Here is the flare that I'm going to bring this back. So here you're going to see this X-class flare right in here. We'll zoom way in so you get a good view of that. Nice. Nice. All right. Let me just advance this. Let's see. Oh, we got to go to a different monitor here. Let's go to Udaipur, India for this one. Let me shrink it down a little bit more so we get the... Wow, look at that flare too. That was rad. Hold on, let's go back. Look at that. It's probably a cloud going over there. That's probably a cloud, not the flare. There goes the flare. And so a bunch of that filament stayed intact, but anyway, I'll let this play through for you for your viewing pleasure. Still lots of Earth-facing filaments here. So a ton of large coronal plasma filaments on the Earth's side of the solar disk, and the likelihood of still more geomagnetic storms, solar storms, whatever you want to call them, the likelihood really high. So yeah, we love it. We love it. Yeah, thanks for tuning in. You're welcome for the updates. Space weather is basically a bodily function for me at this time. We did these daily videos every day for over 6 years. So this is all old hat. And I give 0 Fs about anybody's concerns about my new hat. 0 Fs. Anyway, once again, there's the view from Udaipur, India, showing the X-class flare as well as the filament ejections. You can see this filament here, a bunch of it blasts off, some of it remains anchored to the chromosphere, or perhaps the corona. Maybe even the photosphere. Who knows? Who cares? If you know the difference, let us know in the comments the difference between the photosphere, chromosphere, and corona. Electron flux back into storm territory here, so expect GPS errors, especially between 10 and 2. Let's check our ionosphere to show you that the South Atlantic anomaly is in the Pacific Ocean. No other channel is covering that. I don't know why. The space weather hacks who are telling you that it's very scary, it's dangerous, it's doomsday, oh my God, we're going to die. Those dummies don't show you the ionosphere, do they? But we do. So there it is. There's the ionosphere in megahertz from the Australian Bureau of Meteorology. This is showing the anomaly for the F or F2 layer, depending on it's day or nighttime. But look, the South Atlantic anomaly is way the heck up here, not way down here by the 30 latitude line. It's way up here by the equator, right there. You can clearly see it. Here it is on the raw map. This is anomaly in megahertz from a 30-day median. That's the previous day. And here is the raw megahertz. That's showing you how fast the ionosphere is vibrating. And it's not very fast, okay? So, 14 megahertz is what the ionosphere is vibrating at. That's 14 cycles per second. And that is over the noontime part of the planet. So the ionosphere puffs up in the daytime. So around here, you get an F2 layer, but on the nighttime side, you only get one real layer of the ionosphere because it deflates at nighttime because of a lack of solar inputs, that is infrared, ultraviolet, etc. Continuing on, again, here are the last couple of hours, and look at the volatility here. The likelihood of additional X-class solar flares is like 60%. And as this gets closer to the limb, it's going to go up to 64%. Yeah, 64%. Now that's the last couple of hours. And what a great day for space weather. Anyway, I was talking about the ionosphere, so here's a little map for you just so you understand. The ionosphere, it puffs up in the daytime. You can see it gets taller and it gets lower because it puffs up both on the bottom and the top. At nighttime, it shrinks down and you just get the E and F regions. In the daytime, you get a D region, an E region, F1, F2, F3, F4. You get multiple shell layers. That's just the way it works. So anyway, that's our space weather coverage. And we're going to close out today's video with some, let's look at 284 angstroms because it's just beautiful. This is one of the ionized iron species. And it's just pretty cool. I mean, it's a little bit oversaturated there. And I could mess with the controls, but we're just going to leave that alone for now. Let's also show 195 angstroms. So, and what's interesting here is that There actually are a bunch of coronal holes, but there's so much plasma suspended in the corona that the coronal holes are being obscured by all of this activity here. These are very three-dimensional regions. So these are like puffed out towards you. If you looked at it from the side, the corona would be really, really lumpy on the Earth's side right now because of all these active regions. Their magnetic fields are suspending the solar plasma in the corona. That is how it works. And this 171 will actually show you a very good, we're going to zoom way in on that. So you'll actually be able to see where the flux ropes are located here. So you see all of these loops. These are magnetic field lines that stretch. They're closed lines that have both ends in a sunspot or active region. There you can see a great view of that in the house favorite 171 angstroms wavelength. It's just gorgeous. This is my favorite wavelength of the closest star. I mean, just look at how cool that is. Coolness factor is way up there. Continuing right along, we'll also show 94. Going to zoom way on this active region. Again, an X flare could happen at any moment, folks. So don't be surprised to see all kinds of issues with communication systems, radio blackouts, exposure to additional radiation for polar flights and astronauts. Space weather is lit up like Christmas right now, baby. And I feel like I'm at Christmas because this is a gift to this channel. Just like you viewers are a gift to this channel. And we're thankful for having each one of you. Anyway, time for this thing to be closed out. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And until tomorrow, maybe even later today, may that solar wind be at your back. Oh, I was muted. Sorry about that. Just a little side note. Please press share. We're going to leave a link in the comments pinned so that you can see our homepage. Please visit the homepage, click the links, check out the merch. There's more merch coming out soon. And yeah, thanks for supporting the channel. Congratulations on realizing it exists. We'll see you soon with space weather on the way.